All right, I want to talk about acceleration now that we've covered average velocity versus instantaneous velocity. Acceleration is going to be represented with a lowercase a. It is a vector, and it's measured in meters per second squared. So what we need to know about acceleration is that it's the rate which velocity changes. So since it's a rate, that tells us it's with respect to some time. And we're looking at a change in velocity in that time. So there are three different ways we can accelerate. If we're changing our velocity, that means we can change the magnitude of the velocity. So that gives us two ways. We can slow down, we can speed up. Either one of those is acceleration. Since velocity is a vector, we can also change direction, and that would be a way to accelerate. And to calculate average acceleration, we would take final velocity and the initial, the difference between the two, and divide by the time interval. So here you can see the top portion would be meters per second, and the bottom would be seconds. So that's how we get our units meters per second squared. If we were to take a look at this setup, that looks like a slope equation. So what we see is that for a velocity time graph, where our rise is v naught to v, and this is our time interval, we get that the slope of the graph is our acceleration. And for this class, what we're typically going to assume is if we're finding an acceleration, we're finding what we call a uniform acceleration. And that's when the acceleration is constantly occurring and the magnitude of the acceleration is consistent. So that's what we mean by uniform. If we get a constant slope here, uniform acceleration. So we mean that it's constantly being applied, or the acceleration is constantly occurring and at a consistent value. And that's acceleration. We're really just looking at the difference between two instantaneous velocities and how quickly the change is occurring.